Three on one. You know, if you don't want to get hit by things in this world, there are a lot of things you got to look out for, including stuff being thrown at you by nasty people. I mean, there's paint that could fall off ladders, rocks that could fall off cliffs, and rocks that can fall from the sky. Hi, I'm Bob McDonald. Did you know that every day thousands of bits of space junk fall down from space, and every now and then one of them is really big and it does a lot of damage? So, put on your hard hats and keep your heads up, because we're going where it's raining rocks. Did you see that? Look, there's another one. And another. They seem to happen so fast, you're not even sure you saw it. Wow, that was a big one. They're shooting stars. If you go out on any clear night when you can see the stars and just look up for a long time, I mean, really a long time, don't just look up, but take your time and really stare at the sky, you might see a quick flash of a meteor. Now, sometimes they happen so quick you're not even sure you saw them. But those are the meteors. Some nights are better than others because meteors tend to come in showers. And one of the best showers is in August. It's called the Perseid meteor shower, and it happens in the second week of August. So get out a calendar and mark the second week of August, and then the first clear night you get, go outside, look up for a long time, and you will probably see a whole bunch of meteors coming from the constellation Perseus. And in August, that's in the northeast. The Perseid meteor shower happens every year because the Earth plows through a path of dirt and ice in space. This dusty trail was left behind by a comet a long time ago. When the bits of dirt hit our atmosphere, they produce a meteor shower. But remember, when you see the meteors flashing across the sky, you're not just seeing how fast these little particles move, you're also seeing how fast the Earth moves through space. Space is not as empty as it seems. There are millions of rocks out there, some quite large, and others as small as a grain of sand. What's important is that they hit the Earth all the time. Actually, we run into them as our planet races around the sun. Fortunately, we have a shield that protects us most of the time, our atmosphere. Most of the smaller ones burn up when they hit the air. The little particles are traveling thousands of kilometers per hour, and at that speed, friction from the air heats them up to very high temperatures. For a second or two, they shine as bright as stars shooting across the sky. They're not really stars, they just look like that. Shooting stars are just falling space stuff. And if they hit the ground, we call them meteorites. J.J. Cavallard studies the stuff that falls from the sky using a big telescope in Victoria. He collected some meteorites to show me what they look like. So what are we looking at here?
Well, we're looking at little bits of rock that have hit the Earth. They've come from outer space and they've impacted us.
Okay, these are actual space rocks?
These are space rocks.
Okay.
These are...
They look really different. What do we got?
Well, we've got a bit of an iron meteorite here.
Holy cow, well, look at that. That's really beautiful.
Yeah, it's lovely, shiny, and strong.
Now, you cut this, okay? It didn't come
That's been cut away so we can see what's inside there to get an idea of what the meteor's made from.
It's really heavy.
Yeah.
It's made of iron?
It's made of iron, yeah.
Okay.
And then, well, and here's a much different one. It's also been cut away, and it's a stony one. It's completely different in its composition, and it feels very different.
Yeah. And then another little bit.
And then a little bit another of a stony
and this
one
guy.
there. And then here's a nice, great, big, heavy one that is sort of a mostly iron one. It's very dense material. If you feel that, that's incredibly heavy.
It's really, but it looks different on the inside than this one does.
It's got a sort of not as smooth, not as well. It hasn't been cut as smoothly either. But if you look here, you can kind of see there's basically different kinds of material.
And it's black.
It's black. In fact, that's a very interesting thing about asteroids out in space before they impact the Earth. They're very blackened surfaces. They're coal black surfaces. They're hard to see because of that. They don't reflect a lot of light.
what is all this stuff that's out in space? I mean, how come we're getting bombarded by these rocks that are falling out of the sky?
What we're worried about hitting the Earth is these bits of rock are leftover debris from the formation of the solar system. This is the stuff that didn't turn into planets. And planet formation is not a very efficient process. So most of the stuff that was in the original solar system actually never turned into planets and basically just eventually evaporated away or is hitting the Earth.
So when we see shooting stars in the sky, what are we actually seeing? Is this the stuff?
Well, what you're seeing is actually not even something this large. When you're looking at a shooting star, you're looking at a tiny grain of sand burning up as it goes through the Earth's atmosphere. And this tiny little grain of sand, as it burns up, gives off this beautiful glow of this shooting star that you see. And those little bits of sand are actually debris left over as some other object was passing near the orbit of the Earth. And that dust basically slams into the Earth, or the Earth goes through a dust area, and you see the shooting stars. And that's why they happen the same time of year. You have these various events that are associated with particular clouds of dust.
This leftover stuff in space comes in all different shapes and sizes, from tiny bits of dust to jagged boulders the size of mountains. Most of it's too small to be seen, just little specks of dust that don't do much harm. Some are the size of sand grains, like you find on a beach. Those give us shooting stars. Then there are pebbles, rocks, boulders, and the really big ones, many kilometers across, that are called asteroids. Oh, and there's one other type of space rubble out there, snowballs. That's right, way out beyond Jupiter, far, far from the sun, where it's very cold, there are giant snowballs floating through space. Every once in a while, one of these snowballs drifts in towards the sun, where it warms up. The ice turns into mist and vapor and forms a beautiful long tail that we can sometimes see arching across our skies. Those are comets. But while they're lovely to look at, comets, asteroids, and all the other space dirt out there share the same space with our planet. The Earth is always running into this stuff, and most of the time we don't notice it. But when a big one's heading our way, it's time to watch out. Boy. This is a place you would not want to have been 50,000 years ago. That's when an object from space crashed to the ground here in Arizona and produced this giant crater. It's called Meteor Crater because the space rock that hit here is called a meteoroid. And it's hard to believe that this kilometer-wide hole in the ground was created by an object only about the size of a house. There's a whole belt of asteroids circling the sun between Mars and Jupiter, millions of them. There's another belt with millions of snowballs out beyond Pluto. This leftover planet stuff is the dirt on our cosmic highway, dirt that our moving planet is always running into. So why are shooting stars shooting so fast? Well, that's because they and we are moving fast. Now, here's something we don't tend to think about, but our planet is moving through space. Think about it. Every year we have to travel all the way around the sun, and that's a long way to go. And the Earth is moving through space at 30 kilometers a second. That's 100,000 kilometers an hour. I mean, think about that. This jet plane that's flying overhead, it's doing 500 kilometers an hour. The Earth is doing thousands of times faster than that just by moving through space. The objects that are out in space, these rocks, are moving just as fast. So when we run into them, the speeds are enormous. Now, most of the things that hit us are really, really small, and they burn up in the atmosphere, and we don't have to worry about them. Those are meteors, and they give us beautiful meteor showers. But the bigger ones can make it all the way to the ground, and they're called meteorites. And by the way, a good way to remember that, a meteorite might hit you in the head. Of course, I guess if it did, that would make it a meteor wrong. Ha, get it? Yeah, okay. Anyway, the one that hit here was a fairly large object made of iron, and you can see a piece of it here. It's all charred and burned from going through the atmosphere. This is just a very small piece of it. The actual one that hit us was about the size of a house. But it's heavy and it was moving really, really fast. And it's those incredible speeds that enable a fairly small object to do a lot of damage like this. Rocks have been falling from space for as long as the Earth has been a planet. In fact, the Earth, Moon, and all the other planets were formed from space debris that came together long ago to form large balls that eventually became the worlds we know today. But while these objects created our planet, they've also destroyed life on it. It was the fall of a large object from space that wiped out the dinosaurs 65 million years ago, an event that's happened more than once in the Earth's history. Scientists think that an event like that could happen again. So how do we know when the next big one is coming? Well, we keep our heads up. If you are worried about another big asteroid hitting the Earth, here are 3 people who are watching out for you. One of them is looking for big objects out there. One of them figures out which ones could hit the Earth. And one of them has thought about what we could do if one's heading our way. Together, they represent the eyes on the skies to protect our planet. Most space rocks come from an area of space called the asteroid belt, which lies between Mars and Jupiter. The asteroids are chunks of rock and iron that either came from an object that broke up or are leftover junk that never became a planet. We've seen a few asteroids close up with our robot spacecraft, and they all look like potatoes. Really big potatoes. One asteroid called Eros was followed for a year. We saw how it slowly tumbles end over end as it wanders through space. If an object the size of Eros hit the Earth, it would wipe out most of the life on the planet. Just as the dinosaurs were wiped out by an asteroid 65 million years ago. The problem is, we don't know how many big objects are out there. That's what Jim Scotty is trying to find out. He's operating an automatic telescope for a research project called Space Watch, which is keeping an eye out for dangerous asteroids.
Well, the threat is very real, and it's a matter of when the next impact will happen, not if the next impact will happen. The only question is when it'll be, which object it might be, how far in the future we might find something before such an impact. So our goal would be to find all the asteroids we can, find all the asteroids big enough to cause significant damage on the Earth, and make a big catalog of them, keep track of where they are, and hopefully we'll find such an asteroid hundreds of years before an impact will happen.
Almost every night, the Space Watch telescopes search the skies looking for asteroids. They're hard to spot at first because they look like dim stars. But if you watch long enough, they give themselves away.
We look for objects that can hit the Earth by taking 3 images half an hour apart of the nighttime sky, someplace on the sky. You'll see images of galaxies and stars and all sorts of other things, including little asteroids. The asteroids look just like stars, except that they move across the sky. And we're looking for fast-moving asteroids, not just the average asteroid. We find thousands of asteroids every night, and hopefully a few of these little asteroids that might hit the Earth someday.
Astronomers know that there are millions of asteroids out there, and most of them will never come near the Earth. So, how do we know which ones are dangerous?
Well, depending on how big an asteroid you're interested in, we're interested in objects we think can do enough damage to the global ecosystem if one hits, and we think that is about 1 kilometer and larger. There are probably more than 1,000 of those objects that could hit us someday. So we need to find all of those 1,000 objects, and we're well over the halfway point now. And we'll make a catalog of all their orbits, project them into the future to see if any of them make a close approach, a close enough approach that we might worry that it might hit us at that point.
1,000. That sounds like a lot, especially since it only takes one of them to make a really bad day on planet Earth. That's where Paul Chodas comes in. He's developed a computer program that figures out which asteroids could hit the Earth and when that bad day might happen.
Well, once an asteroid is discovered, we know very little about it. We know its position at one point in time. And if we get to track it for a night, 2 nights, 3 nights, then we get a preliminary idea of what its orbital path is. Of course, we don't know how far away it is when you just see a point moving on the sky. That can only be inferred by using the known laws of gravitation. And there are only certain orbits which will fit a given pattern of motion. And as you track an object longer and longer in time, over weeks and months, you're able to determine its orbit better and better. During this process, we compute the orbit and run it forward for decades to try to see if it will come anywhere near the Earth. In particular, if it might hit the Earth. And we try to establish a probability that a given asteroid might hit the Earth.
So, are there any out there that we should be worried about?
Every now and then, because we're discovering so many asteroids, there are very interesting ones that come along. And recently there was one that is actually the record holder. The nearest asteroid approached to the Earth, which was only about 26,000 miles above the Earth's surface. Very close indeed. And that one we were able to say would miss the Earth. And in fact, running its orbit 100 years in the future, we know that it won't hit the Earth anytime soon.
Here's the orbit of that asteroid and the orbit of the Earth. You can see they cross each other, and it looked like it was headed straight for us. Fortunately, the computer can show the same scene from the side, and when we look at it that way, you can see that the asteroid passed over top of us. Whew, that was close. As astronomers find more asteroids out there, this will probably happen again. There are likely more close calls with planet Earth than we think. So we have all these rocks flying around out in space, and every now and then one of them comes crashing down and hits the Earth. The dinosaurs didn't see their space rock coming because they didn't have telescopes. At least I don't think they did. But we do. So we can spot these asteroids before they hit us, and maybe we could do something about it to try to avoid the disaster. The trick is we have to spot them well before they get here, because if they're really close to the Earth, there's not much we can do. They're going to hit us because they're already here. However, if we can catch them when they're a little farther out, the Earth is actually a pretty small target, and it's easier to miss it. So we don't have to nudge the asteroid as much if we can catch it early. All we have to do is, first of all, spot it, and then figure out how we're going to nudge it so that it misses the Earth. Boy, am I ever a lousy shot. That's where David Morrison comes in.
If an asteroid is on a collision course with Earth, and you have decades of warning, then you just have to change its orbit a slight bit. You need to give it a little bit of a push. And one design, for instance, is to build a spacecraft, and in fact, we're constructing some of these, with a ion engine, something that pushes. And we put the spacecraft up against the asteroid, we fasten the spacecraft to it, and we turn on the engine for months and gradually change the orbit a little bit. Another way would actually be to use an atom bomb, a nuclear bomb, and explode it above the surface. And that would probably also give it enough of a shove, although we aren't sure exactly how it would react. And so, you know, if we have some leftover nuclear bombs we don't really want, that would be one way to use them, and ultimately would be not to endanger the Earth, but to protect the Earth.
What about Hollywood's version of trying to blow it up with a nuclear bomb?
I wouldn't want to blow up an asteroid, because if you blew it up, the pieces would still hit the Earth, and it might be worse than the original one. So it's much better to give it a push than to try to break it apart.
So far, there are no spacecraft ready to go out and move a dangerous comet or asteroid out of the way. But there is one designed to smash into a comet. The mission's called Deep Impact, and it was sent out to deliberately run into a comet so scientists could see what the comet is made of. The target is a comet called Tempel 2, which passes close to the Earth every 5 years. Deep Impact was sent on a 6-month trip to catch up to the comet. Then it released a probe that ran straight into it. The probe is about the size of a garbage can, and it weighs 500 kilometers, about as much as a motorcycle. If that doesn't sound like a very big object, it's not. But it's traveling very fast, 10 kilometers per second. That's 35,000 kilometers an hour. When an object moving that fast hits something, it makes a big hole. Cameras on the probe take close-up images all the way down, while the mothership watches from a safe distance. The impact creates a hole the size of a football stadium, while material from the comet shoots out into space. Comets don't have much gravity, so the stuff that shoots out of the hole travels a long way. The probe is destroyed, of course, but the mothership watches the plume of material and, with special cameras, measures what it's made of, which is mostly ice that's dug out from inside the comet. This collision didn't move the comet very much. In fact, the probe was like a fly hitting an elephant. But it does show that we know how to send rockets out to meet with these wandering space balls and nudge them if we need to. Future rockets will have to be larger and more powerful, but the idea is the same. So far, these are just ideas in scientists' minds, because there actually are no rockets that are able to go out and actually nudge an asteroid out of the way and prevent this kind of thing from happening again. So should we be worried?
Yeah, a little bit. But you shouldn't lose sleep over it. Well, I do, though. So you don't have to.
Absolutely not. No, we do not lose sleep over this, nor do my kids. In fact, when we find a new asteroid, occasionally, I have to go home and use our home computer to do a little extra orbit calculations. And they say, oh no, here comes an asteroid, we can't play our video games. So.
Did you know that the Earth has a second moon? It's a tiny space rock about the size of a house, and it was discovered in 2003. The object follows a strange orbit around the Earth. Rather than following a circle like our regular moon does, this little moon goes ahead of the Earth and then behind it, sort of like a dog on a leash that wanders all over the place. Scientists believe this little satellite was an asteroid that came very close to the Earth and was captured by our gravity. But it's certainly a weird world. Now, it would be a lot of fun to play on an asteroid because these objects are so tiny, they don't have very much gravity. So that means your body would weigh almost nothing. And if you wanted to move around on an asteroid, you don't walk, because every time you take a step, it causes you to float off the surface, and it takes a long time before you come back down again. You'd be like Superman. You could fly wherever you want to go. And in one case, you could actually be like a fly on the ceiling. There's an asteroid called Ida, and it's the only one that we know of that has a moon, a tiny little chip called Dactyl. Now, Dactyl is so tiny that if you stood on it, you'd weigh almost zero. So imagine standing on the little tiny Dactyl, almost no weight to your body, and you look up and you see this giant asteroid floating straight over your head. It would be like a huge mountain that's about to crash down on you, but it doesn't. And because you don't weigh very much, you would be able to leap straight up. Whoa! And you would float between the two worlds. And along the way, all you need to do is just turn your body in the opposite direction, and you land on the second one. Except now, down is in this direction. Of course, in space, we can make down any direction we want. That's kind of cool. Now, suppose you want to play a sport? Okay. How about low-gravity baseball? Now, you don't need a team for this. You can do it yourself, and you play all the positions. So what you do is you start out as the pitcher. You go to a nice high spot, that'll be your pitcher's mound, and you wind up and you give the best shot you can right towards the horizon. Now, when you throw a ball on an asteroid where the gravity is really low, your arm will do to that ball what a rocket engine does to a spaceship on Earth. You'll put the ball into an orbit all the way around the asteroid. Now, it'll take about 20 minutes for the ball to make it. So, go have lunch. Then, 20 minutes later, you come back and you look in the opposite direction and the ball should come back to you. So now, you pick up a bat and get ready for it. Now, you got two options here. If you happen to hit the ball and you hit it really right, the bat will give the ball so much more energy that it'll fly off into space and you'll never see it again. Home run. On the other hand, if it's not a good pitch, and you miss it, hey, don't worry. It's gonna go into orbit again and it'll go all the way around the moon one more time. So, go have more lunch, I guess. And then 20 minutes later, come back. Now you have a choice if you come back, you see. You can either try for strike 2, or if you're getting tired of this game because it's already taken 40 minutes, become the catcher. Wait for the ball. All right, baby, corner, pitch it in the corner, baby, come on, pitch it in there, let's get a good run. Low gravity baseball on an asteroid. You can do it all yourself. If you want to see what happens to worlds when they're hit by space rocks, look at the surface of the moon. Every one of those round holes, the craters, was made by explosions from a space rock or a comet hitting the moon. Mars looks the same way. So do all the moons of all the planets. You can see some craters on Earth, but not too many because wind and rain have washed most of them away. But almost everywhere else we look, worlds have been pounded by stuff falling from the sky. Now, you can make your own impact craters at home, and all you need is a large bowl, some flour, and some water. Now, I just took a bag of flour and put it here in this bowl. Flour is really fine stuff, and all you need to do is to shake it a bit to make it nice and smooth. Maybe tap the bowl so that you get a nice smooth surface like this. That represents the ground. And for our objects from space, just use drops of water. So drop it from a fairly high distance and watch what happens as these things come down and hit the flour. We get little impacts on the surface. And if you do this enough, you will get a surface that looks like the moon. Whoa! Little tiny explosions happening every time. Imagine the strength of the explosion that made this crater behind me. It's unbelievable. Well, that's our show for this week. Remember that rocks do fall from the sky, and when it comes to meteorites and meteoroids, it's really important to keep your heads up.